There are engineers developing soft robotic materials to replace missing parts of the human body. For example, a finger damaged in an incident or a muscle in your arm that no longer works. This is also the age of 4D printing, which allows for the creation of shape-shifting products that will alter military strategies and commercial applications for the foreseeable future. Hi, I'm Daniel Apo, host of the Hard Tech Podcast and a founder of multiple hardware tech companies. In this episode, I discuss with Yonas Tadesse, a professor of mechanical engineering at the University of Texas at Dallas. Yonas is a highly published, cited, and respected researcher in the fields of soft robotics, humanoids, and other fascinating areas. Today, we dive into his background, his groundbreaking research work, and much more. Please enjoy. We will eventually get to the topic of humanoids and some of your work in robotics, but where did your interest in engineering come from? Can you just give us a quick background on that?
First of all, thank you so much for the question.
Yeah.
So my engineering background interest came, I think it's an inherent, naturally. I am someone who'd like to build things and see their effect, it's some kind of automated system is something inherent in myself, and looking at the family members and relatives who accomplished in the engineering areas, from electrical, agro-engineering, and in these areas, I think my interest came through that line.
Okay, so you have a very strong family connection to just building things in general.
Yeah, absolutely.
That's very fantastic. And then you went all the way from studying engineering to becoming a professor of mechanical engineering. Did you always want to be a professor? Did you always want to teach? Was it always something you always wanted to do?
Yeah, it's not actually always want to teach.
Yeah.
So being a professor is not only teaching, but just mainly also research. So it's a kind of something that's a blend of teaching and research and service.
Yeah.
So we do this balance, this aspect, and the area is really engaging. So, and you must have excellence in all of these, actually, in at least in the two of them, the teaching and the research. That's what a professorship is.
Yeah.
Mainly. Mm-hmm.
So, but did you, were you always interested in being a professor?
Yes.
Always, from day one?
Not from day one. I think when I was at high school level, everybody like to see, what would you like to be? When people ask you, I would like to be a doctor. That's what we used to say. And in fact, my first choice was medical doctor when I was at high school.
Yeah.
And engineering was my second choice.
Uh-huh.
And then I joined in the engineering, and then I continue in that. At that time, I didn't know about, for example, what mechanical engineering, or a different discipline in engineering. Engineering, people usually think about, building of stuff, but not the different engineering.
I see. So speaking of your background, you studied at many institutions in different countries, from Ethiopia to India to the United States. Did you notice any difference in the curriculum from country to country? I know, for example, I have friends who studied in Russia, and they will speak about how studying science or mathematics, for example, in Russia is extremely difficult compared to maybe the United States. Did you notice a difference from Ethiopia to India to the US?
Yeah, absolutely. There is a difference, big difference in each. Of course, the core are similar, mechanical engineering everywhere.
Yeah.
The core areas, but there is, I think, it's a big difference. For example, in terms of curriculum, the undergraduate I went to in Ethiopia, it's a very tough curriculum, 5 years program.
Mm-hmm.
And there are, multiple, and if you miss one of the track, one is related to the other one. So your 5 year can be also 6 years. So it's very tough curriculum, but it was based on the German curriculum. When you see I studied my master's in Indian Institute of Technology, that one is also different approach. I mean, it's more computational side, computer related activities, whereas in Ethiopia it's more of the theoretical. I think this is I'm talking about a long time ago, from years ago. But now things are changed. But during that time, that was the scenario. Here in the U.S., most of the courses are homework, assignments, project intensive. It's a blend of these tests, homework, and so on. So you see that there is some emphasis on different aspect of it. So there's slight difference in each of them. Okay. But one thing I must say that is that you can kind of get one important things from all these unique universities. You can learn something different and unique.
Yeah. Okay. That's interesting. So Ethiopian curriculum is based on German German educational system structure,
because they established it. I think
that's interesting. I wonder if they carry over some of that efficiency and with them. Germans are known for being very efficient and making very high quality products in cars and things like that.
Yeah, I think there was the Technology Institute where I was at Addis Ababa University was established by their collaboration with German. And most of the professors actually studied their PhD. They're called doctor engineer, even the title.
The title is doctor engineer.
Doctor engineer, that's how they call it. I think I haven't seen in the US mainly doctor engineer. Just as there are some, but their title is like that. And most of them studied their PhD there. And then they went back and then established the university.
Okay, fantastic. I'm going to jump into a very, very important question about independence in engineering. So if you wanted to start an art company, for example, you could do it by yourself. If you wanted to build a software company, theoretically, you could do it by yourself if you wanted to. But if you wanted to build advanced physical technology, like engineering based, I'm not so sure. And so the question now is engineering a very collaborative space where you can't build technology independently by yourself, especially coming from someone who works in a university environment? What do you think? Could you do it all by yourself as an engineer?
I will say it depends on the target product.
Okay.
So, for example, I can bring the areas of robots, right?
Yeah.
Robotics is highly collaborative. It's hard to do by one person or few groups too. So it just needs some collaborative environment where you have the electrical, mechanical, and computer programming, and in fact some other aspect of biology to itself, like bio-inspiration. Mm-hmm. If you say building of a humanoid robot or social robot, so we're talking about many other things. So it's highly collaborative. That's one. If you look at other domains, like small device level, one can do it by yourself. Especially these days, there are tools available. Let's say to create the computer design model of it, you can fabricate your own printer. And then as long as you come up with a new, innovative new product, you can probably make a build of a company based off that.
Yeah.
So that's why I say depends on the areas.
On the area, I see. So, well, speaking of collaborative work, I want to take you back memory lane a little bit. Some of the best experiences people have is typically based on their experience working with other people or doing something with a group of people. If you ask people, sometimes they'll be like, I remember when I did this work with this person, or I went on this vacation with this person, and those are good memories. Do you have any memorable project or experience that occurred during any of your studies, even all the way back to Ethiopia, through India, through coming to the US, and even being a professor? What would you say is your most memorable project or work?
I will say it's all are different. In all aspect, you have unique experience. I always remember at different level where I was. So let's say even when I did my bachelor, that's our first Bachelor of Science. That's unique experience we have. For example, when we design a machine design class, I always remember that because that's the first class we have. The whole class building, all stuff, creating from scratch and making your engineering design, assembly, and so on. And then the whole night, and when you wake up, the sun rises up. Everyone in the class. I remember that, fourth-year bachelor program.
Yeah.
And then when we did our final year project, I remember that.
Yes.
And in my master's thesis was highly, interdisciplinary. It's a mechatronics project. I remember that. It's optical drive, the CD-ROM drive. Now these days, CD-ROM drive is,
obsolete.
no one is using them.
Yeah.
So, but it's interesting topic. And my PhD also is unique. My work was on bio-inspired robots, humanoid robots. It's very unique. So at each level, I have a different feeling and different opinion I have.
Yeah.
So the most memorable reason when I did for my professorship, this is a project that I've worked on. The musculoskeletal is something very significant to. Because the reason is that that project was focused on making a musculoskeletal system, that is responsible for movement of human or animals, for mobility.
Yes.
And this project was sponsored by Office of Naval Research. And when I received a $500,000 award, I was so excited. So that was a good one.
Yeah, it's always good when you have the money to do the work, right?
Yep.
Okay. Speaking of robotics and just doing work in humanoid robotics, there are many specialties within mechanical engineering. I'm for example an energy guy. I've done energy research for a long time. There's work in many other spaces. There's work in microfluidics, and then there's robotics, right? What about robotics stood out to you that made you decide, from my PhD up to, postdoc research and now as a professor, this is really what I'm going to hone in on? What about that stood out to you that made you just go all in?
Yeah, I think part of it is, it's very engaging. The field itself is like, once you started, you will say how about if I do this approach, different approach? How about if I change another approach? So by itself, some kind of, it leads you to another level of continuous. And the time goes as you are performing that kind of trial on the social robot or the humanoid robot by itself. So because it's very challenging and demanding, and you are changing something and still another problem will come. You solve that one and another comes. So it's it through time by itself is engaging, and also personal interest. I'm someone who enjoy making some stuff, and when I see some progress, I get excited. So that's the kind of nature this research project has, compared to, for example, I do other research, by the way, other than the social robot, humanoid robot is one of them. I do some energy harvesting work too.
Really?
So at the device level, at the energy harvesting, multimodal energy harvesting, that's one of my highly cited work. So those kind of things, compared to the complexity is less than humanoid, because humanoid has several components.
Yes.
And the reason it's engaging is because it requires many effort, many collaboration as well.
Okay, I see. That's interesting. So, as a professor, I don't know what it feels like, but tell me what it feels like to have several generations of students come in and go, and circle through the labs, through the classrooms, and what that feels like. Is that an experience that never gets old, or what?
Just to clarify your question, so when students come in and go,
Yeah, so you have students who come in who you become the advisor, for example, maybe through grad school, and then you also have students that you teach, uh, and then they graduate, and you have a new set of students come in. How does it feel to just have that cycle on
yeah,
and on and on?
that's what I enjoy as actually. So it's just when they come, the students, they come with a fresh, different mentality, different thinkings. Some of them are already excited in robotics. Students from high school, they contact me as well. Just at the high school level, when they want to join in university, they are already motivated. They have seen so many videos and they want to do things. Now, when they join our group, they start looking things from different angle, something that we haven't considered in that direction. So I enjoy that one when there's new students come. And oftentimes in my project, I involve new students in a different part of our project. And that has been very productive.
So I know you said earlier that, you have to be good at research and good at teaching to be a professor, especially in engineering. But let's talk about teaching for a second. What types of engineering classes do you teach currently at UT Dallas?
Currently, I'm teaching. For many years, I taught computer-aided design class for graduate students. That is using computer package to create different designs. And this is a unique course. It's not just like solid modeling, assembly, engineering, drawing alone. But this has 3D printing as well. And a project. Students need to come up with their own innovative design, fabricate it, use the skills that they have, demonstrate analysis, engineering analysis as well, modeling, simulation, and kind of a package. I enjoy that class, and I've been teaching that for a while for graduates. That's one of them. And similarly, for undergraduate 300 level, I have been teaching that computer-aided design class. I also teach smart materials and structure. It's another course. That's for graduate only. And soft robotics is recently I start offering for the last 3 years. And I've taught 7 courses at UT Dallas so far, and these 4 are some of the main.
Nice. So, what was really interesting is you're talking about smart materials and structures, and I'm just thinking about back in grad school. Just a little bit of backstory. You left Virginia Tech before I got in, and smart materials and structures is one of the strengths of the research center there. It just got me thinking, and it's got me thinking about your students and the people doing research with you. Do you think the stereotype that they're introverts do you think it's true? That engineers, especially the ones that are research focused, are introverts?
Yeah, generally people think this stereotype is always there, but that's not necessarily true.
Yeah.
Right? There are engineers who can, explain very well and discuss in a collaborative environment. I think this stereotype came because people think that engineers focus only some dedicated solitary work and stuff. Perhaps that's why they think, but that's not the case. So oftentimes, most of the engineering project requires collaborative communication, discussion, and that's not true in general. And in fact, in my class, I enjoy discussion. Let's say for the first 20, 30 minutes, sometimes we spend discussion only before going deeper into the subject. I enjoy that one because I want to see focus from this side, from that side. Oh, another aspect.
Yeah.
So that's not necessarily true.
That's not necessarily true. So it means so you're saying that it doesn't affect any type of collaboration work between research groups or in classes or anything like that. So you don't see any introvert behaviors and people trying to disassociate themselves from groups?
Some, yeah, you observe
Okay.
that. You observe that one, but not generalization is always
Tradition is always good. Yeah.
not always good. Right?
Well, that brings me on to a question about student mental health crisis and what students went through during COVID. And as a little bit of backstory, you were telling me about this engineering building here that was built in 2019, and because of the COVID-19 situation, you guys didn't occupy the building for a few years until after the COVID period died down a little bit, right? So, thinking about the students, do you think student engagement and interest in studying and just being present changed over time, especially during the COVID-19 crisis?
Yeah, I think generally students, COVID has affected in many ways the way we interact with people, the way we learn, and things like that changed a bit, right? So behavior of students also changed a little bit partly because of COVID, and after COVID, there are many resources available. For example, some students, they think that whatever you talk, sometimes they don't listen. Some of them, I'm just saying, just some, okay?
Yeah.
Because they think that they can catch up or watch some other resources to learn about it. So you see it's a very dynamic situation. For example, I can talk about 10 years ago, the students that I mentored and I teach, that I taught, versus recent, right? So you see this is there is a continuous change in students as well because of the available resource already. Right now, these days, we have AI, chat, GPT, and so on. Students, it enhances learning, and that information is available. So now we are in a different era of teaching and learning process. So obviously, it's changing.
Yeah. That's interesting. That's interesting to know. Let's talk about the engineering curriculum and just engineering schools in general. I know you're at UT Dallas, but you probably collaborate with some other universities. Do you think, based on the rapid rate of development of technology, humanoid, AI, and all that stuff, that the curriculum is up to date?
I will say it needs dynamic changing as well. So curriculum should be changed a bit somehow, modification, not just entirely change it, because, for example, mechanical engineering, the core fundamental of mechanical engineering, you have to teach that one. Dynamics, for example, thermodynamics or dynamics, statics and dynamics. These are core fundamental classes. But some of these AI stuff, that should be, statistics and it's all mathematics and statistics, actually, this AI stuff, right? So those kind of things and the different methods of AI and algorithms and so on, that should be incorporated in the curriculum. And many universities are doing that, actually.
I see. So we definitely need to see some updating across the board.
Yeah.
For sure.
I think this is agreeable by many.
Okay. But specifically in terms of what some schools are doing, how are they preparing students for the real world? I tell you something. So I don't know if this applies to mechanical engineering, but for computer scientists, for example, students in college studying computer science, many of them are like, it's like their degree is a waste of time, because AI can write software, AI can write code, AI can do all kinds of things. I'm pretty sure humanoids and some form of advanced technology probably is encroaching into the mechanical engineering, electrical engineering, physical engineering spaces also. So how do you think we're preparing students for the real world right now, for a new reality completely, a new work environment, a new job search environment? Are we preparing them properly, or are we setting them up for failure? What do you think?
I think we have to look at based on different disciplines too, right?
Yeah.
So not everyone should learn AI. Study or graduate with AI and other stuff, right? So, but based on the different areas, I would say it's good to learn multidisciplinary from all these different components, at least for few credits from different discipline. But ultimately, the main focus is that in one discipline you just concentrate and widen your knowledge and curiosity and problem solving in that area. Okay, for example, I can speak for mechanical engineering, right?
Okay.
So a mechanical engineer should solve any kind of problem related to mechanical systems mainly, and then of course when you add AI to it or automation, basically you're solving the problem the industry has. Other areas may not solve it effectively. For example, computer engineering, computer science, or other discipline, because in core fundamental of mechanical, as you know, right? So mechanical engineering, we design a device using computer solid model. We create the keeping in mind of manufacturing, the design philosophies. What kind of philosophy will we follow in order to fabricate the device and use for ultimate product? So that aspect, the students should be equipped to have that in their background knowledge and then go to the industry and to solve problems. So we're giving them all this required skill. I have many graduates who are working in industry and successful. So we're giving enough information, but on the top of that, some kind of elective or course that support AI should be provided.
I understand that it's for physical engineering fields like mechanical engineering. It's still very okay, and as long as you understand the fundamental principles and you become really good at what you're studying, and you become really good at something, then you should be useful out there in the world. But for some other fields, it's really brutal out there. You know, if a large language model like a ChatGPT or something like that can do your work, then you're done, basically. You know, so it pays to be. It pays to study mechanical engineering at this point, I guess.
Yeah. So there are things that those models can solve. There are things that this advanced AI model can solve.
Yeah.
Especially things related to physical. They can guide you based on available information, but you have to see skills, right? For example, even soldering. I will speak about that tiny things, soldering. Soldering is a big deal. Tiny misconnection, something that's loose connection, you may end up spending the whole afternoon figuring out those things. Those skills, you know, should have. One has to learn that skill in order to solve problems. Right?
Yeah, I had a guest on the podcast a while ago, and he was telling me about how these large language models. He was trying to get one to write a chemical equation. And it was able to write a very simple chemical equation, but when it comes to something that is useful to actually build a product, to power a process or a chemical reaction or something like that, it was just messing up. That brings me to a question: would it be a more useful skill, especially based on where we're headed now with technology, to basically learn how to teach an advanced automated system how to do your work? So as a mechanical engineer, if you think that automation, AI, for example, will replace your ability to design a wheel, for example, maybe you learn how to design the AI or the automation itself to do it, versus trying to make sure you understand the skill that the technology could take over in the next few years. What do you think?
I believe
or do both.
In both.
Okay.
You know, so this kind of things, for example, things we don't know in the future how it goes. So suddenly there was some introduction of technology, and the whole field or focus will be towards that. So having a multidisciplinary skill in knowing a bit of the two, I think is something useful. But you can just focus on, depending on the area, you focus on one aspect, but knowing both will be a good tool, I will say, because AI can't solve any problem. You know? It's just ultimately it's another form of program.
Okay.
You know, with a bunch of data is collected, reading from that, and then it can't replace human.
True. Some people say that, but
Yeah.
there are discussions in different circles about how humans might not be needed anymore at some point. You don't believe any of that?
I don't think. So just
Okay.
solve. It's like a computer program that, for example, multiplication or this. Yes, computer can do much better than human, right?
Yeah.
But they can't replace human in many sense.
True.
In terms of soft, I mean, humans are very complex. I doubt.
Okay.
A lot of people are saying that, but it's another form of programming.
Fantastic. I like your optimism. A lot of people are not very optimistic this way. But let's talk about something very interesting. So 2D printing is very old technology. 3D printing is getting old now. But apparently, you're working on something called 4D printing, and you're actually attending a 4D printing conference in France this summer. Can you just explain what 4D printing is? Tell us a story about it.
Great. Yeah, I'll be happy to explain that. This is another exciting area of 4D printing, which just simply says that the 4D printing, we know the regular 3D printing, right? Everyone has in a garage now 3D printing.
Yes.
Now 4D printing is that, let's say you want something like, for example, a flower that opens and closes. Okay. So after you print it, so that the structure can open and close when you provide some kind of stimulus. That means besides this three-dimensional aspect, there is a time aspect to it. So that's the 4 dimension. The time is the 4th dimension. So you have that 3D, but later on, after it's fabricated coming out of the printer, let's say you heat it up, you just morph completely and transform itself to something that you conceived during the design.
Yeah.
The CAD model that you created, at time t, it can have this shape. Another time, it can have another shape. So, for example, you can make a box from flat. It's a flat thing, so it's just configured itself and become a foldable structure.
So you could make a shipping box out of
a
flat.
There is one paper on that.
There's a paper on that?
Georgia Tech demonstrate that. Yeah.
I'm sure Amazon is going to love that.
Yeah.
Yeah, but that brings me to a question.
The material. So the key is that, what materials, most the research right
I was going to ask you, I was going to ask that next. How is this possible?
So these are smart materials.
Okay.
So the material used for this one is Shape Mary alloy, Shape Mary polymer, for example.
Okay.
Shape Mary polymer is that it's a polymer that remembers its pre-programmed shape. So you can program, let's say, I'm not sure how many people know about Shape Mary alloy, but I love that material too.
Yeah.
Shape Mary alloy, it's an alloy, nickel and titanium. So you can have, let's say, for example, just squeeze it, and if you heat it up, it remembers the shape that it's already programmed.
Yeah.
So it remembers.
Yeah.
So
it has a memory, basically.
It's a memory capability.
Yes.
So similarly, there is Shape Mary polymer. This is a polymer size, polymer type. It remembers its shape. So you can program it to have a different shape by heating.
Okay.
At certain temperature.
That's very interesting.
So that's a 4D printing work.
That's very interesting. So I have a lot of questions now. Aside from the example I gave earlier on about that, you said a paper was already written on that at Georgia Tech about like a flat
box,
flat structure, adjusting itself into a box later on. Are there any other real world examples out there of how 4D technology working in real life?
You see, for example, 4D printing has application for medical, for example. Let's say, especially in the soft robotics domain, let's say you fabricate the structure considering what shape you want to achieve in the future, going into human body, perform some kind of drug delivery or some kind of surgical operation like endoscope, being tiny. You can imagine that you can control after fabricating what the shape looks like. So this 4D printed structure will have medical application in human body.
Yeah.
For drug delivery, or like I said, surgical
Yeah. I see.
procedure.
I see. That opens up a lot of possibilities
Yep.
for.
That's why we established this 4D printing society.
Okay.
So with international collaboration from Australia, from Europe, from Asia, and from US. So we established that to make awareness of this technology, and we started the conference first virtually, and it's been, I think, 2-3 years since we've been doing. Yep.
Wow, that's very fascinating. I think just the medical aspect of it is very fascinating. And I think this could be very great. Just thinking about the possibilities. Could you feasibly print out things that could, like, print out a small house based on this?
Yeah. So there
You
are
could?
3D printed house also.
I mean, there are 3D printed houses. So now I'm thinking, you print a flat structure. If it can sit on the bed of a truck, you lay it on a piece of land, and then it just transforms into a house.
Yeah.
What?
Yeah.
That's possible.
It is. Yes. Yeah. 3D printing now is becoming,
Yeah.
a core method of fabrication. Even from metals to
Yeah.
polymers and composites.
And you could move that into the 4D realm.
Yes.
Easily.
The 4D part is like
I-
transforming.
Yeah,
Okay,
yeah.
Yeah.
I got that
There
part.
are many aspects that can be considered.
I got that part of the transformation. That's what's interesting for me, because I'm thinking about how you can save a lot of space, and you can transport things easily if they could be shaped in a certain way and then reshaped later on.
Yeah.
And especially when you're talking about dead space. So if you're trying to build, like, let's say, a small house that is just one room, that's a lot of dead space within a house. But if that house came flat,
Yeah.
you know what I mean? Like, it's very easy to transport it, like all those mobile houses or things like that. You know?
Yeah. Oh, there hasn't been something like that. So what I was saying earlier was 3D printed house only.
Oh.
Not 4D.
Oh, okay.
4D, I haven't seen some 4D printed house, because when you say 4D is limited for small things currently.
Small things. Okay.
For example, flowers.
Flowers.
Like flowers. So something, you just create the CAD models, and then the flower open and close. They show that. Gripper for manipulating of objects.
Okay.
And a soft gripper. There has been demonstration on that.
Okay.
Like a robotic gripper, things like that is just popular.
Like
these
a
days.
robotic arm,
Yeah.
fingers, and all that.
Yeah.
Okay. That's very interesting. You think some of that technology is being used currently in some of these humanoids we see, online, being developed by Tesla, Boston Dynamics, and other companies?
No, they are rigid robots.
Those are very rigid? Okay.
They are all rigid robots.
Okay.
The hardware is mainly hard robotics, or the rigid, we call it. The soft robots domain requires soft material with modulus, very low modulus, and not hard like metallic.
Are there? Does this mean? But with soft robotics, are you able to offer more degrees of freedom as a result of the fact that it's not hard?
So let me explain about soft robotics.
Please.
The soft robotics, traditionally, there hasn't been consideration of making soft robots in the past. It's just the past 10 to, I think, 2013, the past 10 years, I would say, just became more popular. So this device, imagine, for example, grasping of delicate object and irregular object. In the traditional robot, this is difficult task, manipulation, holding. How do you hold an egg, which is delicate, and you can squeeze it if you just try to hold it hard, right?
Yes.
But soft robot can hold this delicate and irregular object. They can adapt to that surface by conforming their shape. So they have high degree of freedom to conform the shape and hold that object delicately.
Okay.
And even if, let's say, if that robot moves and it hits you, it doesn't hurt the soft robot. But rigid robots, right, they swing, typically they are surrounded by isolation to avoid damage, right? So soft robots contribute by providing high degree of freedom, soft delegation, and safety.
Wow, that sounds like opens it up to a lot of use cases then.
Yes.
Because we've seen a bunch of workplace incidents and even deaths in places where hard robots are being used.
Because, they can kill people easily.
Yeah, it happens all the time. So, okay. Talking about robotics, we actually had Alex on the podcast. I know you know Alex Villanueva.
Yep.
Had him on the podcast recently. And, I was asking him about the robot jellyfish he developed a while back, for asking him if it was for military surveillance. And it was like, yeah, it was. And so he's got me thinking, how often do grad students, PhD students get asked to work on some of these almost top secret projects? Is it frequent?
Yes. So these graduate students involved in such kind of project. But it's a very, very fundamental research. It's not top secret as in general, but it's a fundamental. Okay, which means that that there is no knowledge about that area. How it behaves, and we have to fabricate it, we have to design it, and then study the behavior. So it's just very fundamental that we don't know much about it, and just investigate and to build up new knowledge out of that one. So it's just a fundamental science. Otherwise, if it is top secret, we will not publish it, right?
Okay.
So we published about this study, for example, in the publication we had Alex and I and many, our group in the past, right, published paper how we can replicate a soft robot that looks like a jellyfish. They can use it for military and civilian application, but the main challenge is how can you make such kind of things? No one can do that.
Yeah.
It's hard. We tried, right? So we could push this technology to a certain limit.
Yeah.
But it has artificial muscle in it. It has its own mechanism of developing, growing of their muscle.
Yeah.
And articulation in the swimming. So it's really the challenge is that how can you make, what kind of design, what material you use to make like a jellyfish. But it's very hard problem.
Is it?
But it's not top secret. If it's top secret, it will not be published.
Okay.
Right? So I think there are different projects. For example, some of the projects we have, some of them we don't publish. Those are not publishable.
Yeah.
Some of them these are fundamental, that needs basic knowledge should exist first.
Yes. So setting the foundation, the first principles of technology, and seeing if it works in the first place is what you guys were really working on.
Yeah.
But you think if you had made rapid progress and actually developed a jellyfish robot that could operate all by itself in water, that you would have been able to publish anything?
So there's the level of TRL, technology readiness level.
Yeah.
So technology readiness level, that TRL number 1 and 2, that we don't know much about it, how it works in laboratory scale.
Yeah.
Now before deploying it, right? We have to make things first, study how it behaves in the laboratory scale.
Yes.
After that, after certain level, they will not be published after a certain level, and it has to
That's
be.
what
there.
I figured.
It has to be. Otherwise, especially military level, should not be published, I think.
You think maybe that's what...
Otherwise, everybody will replicate, isn't it?
You think that's what really happened? Because the research started, you guys did the first principles, and then we didn't hear anything about the jellyfish robot anymore.
Yeah, but the thing is, look, so there we have to look at from that first, why do we study this jellyfish, right? So energies, I think one of the fundamental thing is, it's not only from military perspective, you should look at in the ocean environment or from anything, to transport from A to B something, you need energy.
Yes.
So jellyfish takes little amount of energy and swim efficiently. So why is that? So we're trying to understand that, and then possibly make a vehicle that move from A to B.
Yeah.
It could be life-saving mission, right? So it can be moving from one to another, a vehicle that helps save energy so that to transport. So understanding that's what our focus and interest was, and trying to understand.
Trying to use nature, trying to use
Nature,
jellyfish, and trying to understand how it behaves, and trying to use that in for UAVs, basically.
Yep.
Okay, that makes sense. That makes sense. I was just making a joke about the fact that I haven't heard about jellyfish since then, and I'm pretty sure. Because I've hired engineers in the past where they would do PhD work and they would have no papers.
Oh.
Yeah, nothing published.
Yeah, in some cases,
so,
some agencies
because they can't publish
they don't want,
it. Yeah.
Industry also prefer patent application rather than publication, or primarily once a file is patented and then they publish. So it depends as well, right?
I see. So, according to the U.S. Bureau, in 2019 and 2020, business degrees were the most popular major in the U.S., while engineering was number 4 on the list. So people want to go into business more, study business degrees, right?
Yeah.
In your personal experience, especially since you've been here, have you seen an increase or decrease in enrollment in the engineering disciplines?
In our case, I see an increase.
Increase
of students engaging in engineering, and we have very few enrollment in our department, but now department grows. When I joined UT Dallas, we had five. Our program is relatively new compared to others. We had 5 students graduated. Now we have hundreds of them graduating per year in their bachelor. And there has been significant increase. By the way, when I'm speaking just only speaking, not on behalf of department or the school or UT Dallas. I'm just speaking by my own personal, right?
Yeah,
I guess audience will understand that.
Yes. That's very.
I just want to make the disclaimer.
Yes. In no uncertain terms, we're not speaking on behalf of the University of Texas anywhere, either in Dallas or anywhere else. That's understood. Do you think with the current pace of technology that people will be more interested in the physical sciences and the physical technologies than in the abstract and the theoretical and the computational? Have you seen a certain change in sentiment, especially over the past 2 years or so?
I think, a lot of students right now, because of this AI thing, many of students want to do some kind of computer science.
Really?
I've seen some a bit. I see them. I see that aspect a bit these days, especially because of this AI, ML, everyone is talking about, and most students' interest is shifting towards that. And of course, in all these fields, also the requirement of machine learning AI is coming to every field.
Yeah.
So there is some tendency, but physical work still, there are many students who like to build things, make prototypes. That makes you, very, and especially when you combine this AI with something physical, right?
Mm-hmm.
It's very exciting.
It's magic.
Yep. Yeah. It's just combine both.
Yes.
And in fact, the purpose of that is that it's just to automate. Okay, let's say this AI models, things like that, create code for you, right? Now you focus on make this code. Okay, you're done. At least some helper you get.
Yes.
Now just build your prototype and test on that one.
Yeah. So basically you go in MATLAB or ANSYS or Python or some of that software that we use typically for the physical sciences, and basically say write a code to, move this robotic arm in 13 degrees of freedom. And you put the parameters you need, and you don't worry about writing the code from scratch.
Yeah. So that helps. Yep.
Yeah, I see. Okay, that makes a lot of sense. Now, let's get into some of your work. You've hinted at it a lot. Soft robotics, humanoids, and you said you did some energy work also. But so in guiding your students on projects like artificial skin for soft robotics and is it orthopedic or orthotic hands for
Orthotic
stroke?
hands, yes,
Orthotic
yeah.
hands for stroke patients. What's it like guiding them, on such innovative and I would say very, very impactful work? These two projects that I just mentioned, I know there are many more, but these two projects I just mentioned sound like very, very impactful work. So what does it feel like? Does it mean a lot to you personally?
It is. It means a lot to me. So guiding them, students, on something they are excited about when you tell them the story about what
Okay.
our goal is and what we can achieve. So they get excited, and I get mental satisfaction as well when I engage students, especially when you get results. So that satisfaction aspect is there. And plus you are guiding someone, you have a problem here and how to solve it. The process is also very important.
Yeah.
What are the steps that we follow to solve that problem? And then when we encounter another problem, another direction, they are by their own, they will do their own problem solving skill applied to something else. Yeah, so this is really exciting. Most of my students are professors in other university, all of them, in fact. The one I had all my PhDs are university professors now.
It's very interesting.
Except I have just recently 2 PhDs.
Okay.
And they're building their own research to solve some problem.
Yeah. Do you wake up every day more motivated to work simply because of, more motivated to do the research that you do simply because of the impact it's going to have? In the past, you have students working on things for companies sponsoring research that they don't really like. Maybe it's in a sector they don't like. Maybe it's a military company. Maybe it's an oil and gas company. Maybe, but if you're doing something related to healthcare and you're basically helping people, does that help you get out of bed faster, make you more motivated to work?
Oh yes, yeah, absolutely. So
Okay.
just for example, this problem for stroke rehabilitation, the hand orthosis, is important. So just we had, for example, when we test this hand exoskeleton device tested on stroke patients. We worked so hard to make this. It was an innovative new product we proposed, and it was tested on a stroke subject. And we have to do our best to make this device work, function, and be able to help that individual. So it makes, because there are many problems to solve, we strive our best to contribute what we can. So let me explain briefly about what hand orthosis is.
Okay.
So this hand orthosis is basically orthotic device exists in the CVS and Walgreens and so on, but these are passive. So these devices are worn in the hand, and they just, for example, keep the hand in one particular position.
Okay.
But what we are working on is dynamic hand orthosis, which means that, let's say if someone has a stroke, then they lose the hand movement functionality. So what medical doctors do is that they provide a glove, hand exoskeleton glove. They wear it, and basically it will let them move the hand like an exercise with a cycle. So that makes the connection, the lost connection, the brain connection with the hand, and they will gain ability again.
Okay.
So this external device that is supplied for them to train the hand movement.
Okay.
So existing are very expensive in the market. Some of them are not available as well. So we are working on towards that.
Okay.
Solve the problem.
Okay. So your version is basically a robotic version of what already exists?
Yes,
Okay.
it's a robotic version. Yeah,
I
a
see.
recent paper was called NOHAS, Novel Hand Orthosis Actuated by Servo Motor. Basically, the user will wear it like a glove. There are small motors that are attached here, and there are controllers, and this can be controlled by a cell phone. So let's say if you move all the 4 fingers, it will move the 4 fingers and return it back. So it's just a kind of train them. So that stroke person with a stroke, basically during the rehabilitation, when they go home, this kind of training should be provided, let's say 3 times a week.
Yes.
So instead of going to the outpatient in the patient's facility or medical centers, so it can be done at home also in a programmed manner.
That's really, really good. Sounds fascinating. It's something I would like to work on for sure. Speaking about skin for soft robotics, is that the shape memory polymer you were talking about?
Shape memory alloy, yes.
Memory alloy. Okay, so basically, developing that skin is a form of material science, I would say.
Yeah, it has some material science aspect of it, but primarily making from mechanical engineering aspect that we are dealing. Yeah, the skin that we have shown in one of the recent publication was that it's like a human skin. Basically, it has artificial muscle embedded within elastomeric material. It's like a rubber-like material. Rubber-like material, but there are like human muscle, there are actuators embedded into it. And when we supply electric current to the actuator, the skin will bend or contract or morph in a different shapes. So we have demonstrated that these kind of things can be used as a soft gripper for holding objects, also squeeze something and hold irregular object by using a humanoid robot. We showed that a couple of videos on how we can demonstrate. So that was a project sponsored by Toyota Motors Research, which I had a fellowship for 2 years. Yep.
Toyota, it's interesting. Isn't it interesting when you hear that a car company is making robots, and now first it was Tesla making hard robots. Now Toyota is sponsoring soft robotics.
Yeah, because Toyota is their goal is mobility for all. That's the motto. So just the movement part. So anything that morph, configure to different shape.
Yeah,
they have interest on that. The research center of the Toyota.
Okay.
Yeah.
Hey, this has been bothering me a little bit for the past few minutes. What do I do if I'm swimming or not? I probably won't be doing that. But let's say someone in an ocean discovers a jellyfish that is swimming in there, and it doesn't look like a real jellyfish. It looks like a real jellyfish, but it's kind of off. What are you going to say then? That some of that team has been developing the work and no publications, nothing to show for it. I just have a feeling that someone is working on it or they've done the work
to
completely.
Make like real jellyfish.
Yeah, I know you said the goal is to study jellyfish and study jellyfish and to use whatever the attributes of jellyfish are to make unmanned. I said they were UAVs, but they are underwater vehicles, right? Yeah. That's to basically make them more efficient, swim with less energy. Float go underwater and go from place to place with less energy, right? That's the goal. But I just keep thinking that one of these days, some other country is gonna say the US has been using jellyfish to monitor them underwater. I don't know.
They may say, but the thing is that these are all under research. Right?
Yeah.
So we are exploring basic understanding of this material, this kind of vehicles, not like those that are deployed for military.
Oh, hear me out. A 4D printed structure that looks like a flat structure sitting on a seabed, but at any point in time turns into a jellyfish. and then moves around. Yes. And then moves up and down, moves everywhere he wants to go to, and then just goes back into that flat structure whenever it's about to be detected. Tell me that's no one is working on that right now.
I haven't seen. Yeah. So recently in one of the publication that they showed, there are things that we just explored. For example, a few years ago, that the test was done in the deepest part of the ocean, 10 kilometers down.
Okay.
Whether soft robots can survive or not, whether it survive or not, has been explored in one of the publication. They did that.
Okay.
No one has done that before at that much depth of water. First of all, to check whether the soft material can survive or the robot can swim. So they have done that. So that kind of research that scientists are considering right now to answer some of the basic questions we have.
Yeah, but why? Why would they be doing that?
To understand knowledge, to build up knowledge. One of the things is
just to
build up
understand.
knowledge,
and did it survive on the?
Yes, it did.
It did? Okay.
Yeah, it did, and then show functionality.
My theory is correct. Somebody is developing stealth technology that can adjust.
That was a fish-like actually. So,
fish-like structure.
Fish-like, yeah.
Yeah. So jellyfish is just a random example I'm using, but I'm sure there are many other things that they're using.
Yeah, it's a lot of things are going on. The research direction is exploring. But one thing we're noticing is that one can say is that the development of software and the material is not matching.
Yeah.
So just one of them. Now we see this development of the software significantly, but the material is not that much.
Yes.
It takes a long time, or the integration of material takes time. Look at this humanoid also. Just the development is very slow.
Yeah.
Just a few years ago, they just developed 10, 30 years. The progress is not that very significant. For example, Asimo, the humanoid, now Boston Dynamics took advancement and they changed their technology recently. But the progress is not as significant as the software. I mean, there's not matching, I would say.
We'll get to this. We'll get to talk to the Boston Dynamics robots in a sec. But I'm very excited about the advancement in soft robotics and 4D technology, especially. I think that is a lot more powerful than the hard robotics in the long term. Even though you think that it can't do much and some things are impossible. Actually, if you're looking at it and you're looking at the equations and the laws of physics that apply to it and things like that, you can basically do everything else, but you can't break the laws of physics. I get it, but I think there's a lot more impact that can be derived from soft robotics than hard robotics in the long term.
Yep.
Just my opinion.
Yeah, soft robotics, even there are limited studies on the control them and how to manufacture them. So many, how to make them, repeatable, high accuracy and things like that. Just many things going on.
That's really, really fascinating. Really fascinating. Okay, let's talk about your students some more. Do you think that their current projects will contribute to the overall advancements of robotics and the direction of technology now? Like, could you see some of the work, your current and past, like the ones that are professors, for example, also do you see them having a big impact?
Oh yeah, absolutely. So I can give many examples, but one of them, which I try to attempt as well, still very hard topic, musculoskeletal project.
Okay.
Like, for example, how can you've seen these Boston Dynamics, Tesla robots and things like that.
Yeah.
And I mean, these are robotic joints, rigid robots with some kind of motor at the joint that moves up and down. Mm-hmm. But if you look at the bio-inspired aspect of it, like a human, we need to build a human like that. In human, we don't have a motor or a joint. Instead, we have artificial muscle. So the basic thing is that how can one fabricate artificial muscle actuated robotic system that can help human? That's more efficient, impactful. So my group and myself contributed significantly for this aspect. We contributed, but still more work to be done. For example, how do you make, by using additive manufacturing technique, how do you make, just simple start from a single joint, like my finger, for example, I have one joint, another one here. How do you make a skin, soft skin outside, bone inside, which is rigid, the top is soft, and there are nerves also, there are blood vessels as well, so that it articulates in an energy efficient manner. So the current technology is that, these are rigid robots and then some soft things attached and moving it and whole things. But ultimately, the main or the best solution would be to mimic like real nature. I'll come to why to mimic nature. There is another benefit of it. That is more efficient, articulate. It's not too soft, not hard robots, but in the middle of hybrid. Because you see that it has softness too. It has rigid. If you have everything soft, you will not be able to hold hard objects.
Yeah.
That's why human is the most intelligent, developed animal, like similar to animal, but effective in terms of thinking as well. So if we replicate like a real human, we can benefit. The first benefit is assistance, right? The second benefit is that if we can make that musculoskeletal structure, we can make best prosthetic hand for those who lost limbs, with the not rigid, but with soft and hybrid structure, with all intact. So my group, and I'm excited to talk about that. And in most of my publication, I say this also, the problem that we try to solve, and others also contributing. What kind of artificial muscle do you use? How do you fabricate them? How do you model them? And so on.
Yeah. It's got me thinking a little bit. There are two ways to look at this. As humans, we are imperfect, and some of us are really imperfect, right? It's possible someone got into an accident and then they have a brain injury. Someone got into an accident and they lost their limb, or they were just born with a deformity. So that's one aspect in which what you're talking about is very useful. Make that human whole again and make them useful. They lost a finger, replace the finger with some kind of robotics. It's got me thinking even beyond that now. So your work is to basically replace, to mimic human parts, basically. So if you've lost some muscle, let's replace it with soft robotics. If you've lost like a hard part of your body, let's replace it with a hybrid structure, right? That's what you just said.
Yep.
But instead of having like automation and AI outside of the human system, can we just make humans as we are just smarter and faster and more efficient, and just keep everything within the human system? You think that would be a better future than trying to make everything external so that it can now be controlled by just a small number of people and then everyone else is just left to the lurch? What do you think?
So like exoskeleton kind of device that enhance human performance.
Either a physical type of structure or a software-based type of structure that is embedded within a physical structure that just makes humans more efficient, more faster, and all that. So there are two ways. You are very
external thing.
Yeah,
these are external thing then.
Well, it could be in the human brain. It could be it could be in the human
chips,
brain.
like
it could be
chips
in the
that can trigger the brain.
Yeah, or it could be in the human arm, make it stronger. Human leg. It could be anywhere. But I'm looking beyond trying to make a human whole, which seems to be your work, which is how do we, help make parts that will help people, deal with stroke, replace parts that are missing in their body and things like that. But even beyond that, why don't we just develop AI technology and all these technologies that we're developing inside of the human?
Inside of the human, for example, depend on the need also, right? I think this may not be needed at this time, right? And what the most important thing, to the medical field, for example, one of them is, cancer, right?
Yes.
Solve cancer problem. That's even diagnosis of cancer, identifying the radiotherapy and things like that. These are some of the things that are needed right now. And then for stroke, right now, for example, even for the strokes, what are the external device or internal device that help? For example, they put stimulation of the venous nerve stimulation, they say.
Yeah.
They put stimulation to stimulate the nerves and to gain hand function. That's another research that's been the focus, because the problem is enormous. The focus has been how can we solve existing
narrow
problems
focus,
right now.
I see.
That's why most of the effort goes to that.
You see, we're looking at it on two fronts. You're looking at it from the aspect of research, fundamental research, and all the work that you're doing, which is very, very useful. I'm thinking about what's happening out there in the world and what billions of dollars is going into, which is really the external stuff. So while in physical sciences, we're working on humanoids and working on soft robotics and helping people with cancer and stroke and many other types of diseases, people are actually spending billions of dollars developing external forms of automation and things that are not useful to the human body, right? Things
like
that
garments and
yeah,
and other
or even 100% software-based type of technologies. I always think about this. Someone told me something that you could basically get rid of doctors completely very soon, because all you need to do is just find the smartest doctors and download their memory into an AI, and then bam, you don't need doctors anymore. But I thought about it the opposite way. I was like, why don't you feed all of the information from all the best doctors into one brain, one human brain, if it can handle it? And then maybe that person can go on and solve some of the worst problems that humans have in terms of diseases, perform the best surgeries possible. Maybe you download all that brain into a pharmacist. All the knowledge that pharmacists have downloaded into the brain of one's pharmacist. Maybe you could cure cancer. Maybe you could find the medicine. You could find the vaccine for it. That's what I'm thinking. More like, instead of just making it something that is controlled by a few powerful people, why don't we just make it part of the human anatomy?
Yeah, I think that's a great point. These are these fundamental, ambitious kind of projects. Still, by the way,
Yeah.
there are government programs that encourage some kind of, just something that dramatically change or different way of thinking.
Yes.
Which is exciting that government has different program, which is supported by federal level. They encourage this kind of things, but still, I think community is mainly, or the research community, right, focus on solving some of this basic problem mainly, and of course there are some who are looking other aspects or dimensions as well. But I haven't looked critically from that point that you mentioned.
Okay. I think
there are many aspects.
If we really want to do something for the human race, and if we're looking at it from an altruistic standpoint and not from a purely capitalistic standpoint, that would be the best way to go. We would solve almost every problem. Take all of that knowledge and feed it into the human brain somehow. I'm just thinking that would be the best way to go.
Conceptually, that I think it's good to develop the idea, conceptualize it, find approach-wise, and then look at how this can be and the impact and so on. I think that should be taught well and discussed.
Exactly.
It's always good to have different opinion or different angle of looking at problems.
Yes. Let's talk about the most popular thing out there in robotics right now. One of the most viral moments recently is the Boston Dynamics robot, the updated Atlas, right? An all-electric humanoid robot with upgraded movement and intelligence. What do you think about this robot? And I know you've seen like the videos and everything. What do you think about the way it behaves, with the way it can basically turn its head all around, and it has the movements of a human and not the movements of a human? What do you think?
Yeah, I think I was surprised first when I see the change. So suddenly, it's not suddenly, but they have thought about it. Change hydraulic based. I like their robots very. I use them in inspiration for my class. First time when everyone joined my class, they will look at how different robots.
Yeah.
So Atlas is one of them. Asimo I show all the time, and Sophia too. Sophia the robot.
Yeah, Sophia.
So, but recently when they changed this electric motor, I said, oh wow. When they changed from entirely hydraulic to electric based. And I read about the story also. So kind of surprised, but yeah, I think it makes sense as well, because as you can see, the size is smaller, you don't see all the wires and big size, which limits its ability. So I think they change to slightly different direction. But we have been saying this in many of our publication in the past. When we write publication on humanoid, we always say that hydraulics They are bulky, noisy, because you have hydraulic fluid and you have piping systems that transmit, and this makes naturally bigger. So now they changed to the electric part and made efficient. They're very successful in showing very dynamic movement. But that's really great, and I'm thankful to them because they triggered this research in the US. Because in the US, if you see, I've been following this, the publication of the US in 10 to 15 years ago when I started also on this area. US was second. Japan is number one in publication. I think I have saved the graph. It shows that now I checked 10 years ago now we are catching up. US is leading in terms of research, and there are programs like National Science Foundation established a program on robots. So the Boston Dynamics showed a great effort to accelerate this research.
Yeah. So you don't think the robot is scary? You don't think it's because it doesn't behave like a human, like for some other companies, like many other companies, I don't want to mention their names, making humanoids, they try to make it as human as possible, and they kind of walk like a human, move around like a human. Atlas is just like, forget all that. We need something that just moves and just does stuff. It removes the human element from it. That's a good thing to you?
Yeah, ultimately, these are assistive robots. They help humans.
Assistive, okay.
So they help us to. I mean, imagine. Would you like to have a robot at home that can assist you?
I don't know.
I would like to have
You would?
one. Yes, I would like to have one robot that can clean up stuff and wash dishes, and then help go upstairs and then clean up stuff. And also come to arrange the clothes. I mean, these are. See, in other countries, many places there are house workers, right? In the US, I imagine if such kind of, and there will be, for sure, there will be robots everyone will buy at home that help in all these kind of daily activities.
A movie was made about this 20 years ago, right?
But so physically, it should come. But the problem is currently they are very expensive. You will afford like a car, like your car at home, just.
Hey man, people will probably borrow money to buy robots, no?
Some may afford, but not everybody.
Not everyone can do it. Yeah.
So affordability is one of the key parts too.
Yeah.
And plus, how do you maintain this cost?
Yeah.
Maintenance cost.
Yeah. This is a very fascinating discussion. The thing you said about the US and Boston Dynamics, you seem very grateful to Boston Dynamics for driving the research. And obviously they've been doing this for decades, right? They've been developing the robots and showcasing them and showing their progress. So can you paint a picture of the change in robotics research and development over the past 10 years? Just overall, like what type of robotic research did we have 10 years ago and what do we have now?
Yeah, 10 years ago, or at least for the past, not like this. We don't see many. I mean, Japan was showing that, or the Korean Institute of Technology, they showed many robots like that, but not significant in the US. In the US, most of them are, household, or something that articulated movement, industrial. That's dominant in that aspect. But what I said earlier for Boston Dynamics is that I think they engage students, engage young people also to be in this field. It's exciting when it flip and then stabilize by itself. That's very challenging even for a person, right? So that kind of things is very inspiring because in Japan, everyone, when they're kids, they show them these Asimo robots, which they have been developing. And all of them, they know about Asimo.
Yeah.
Now, that's why I was saying earlier that this development changed now in the US also, the trend of the leadership and also the activity. It's not only Boston Dynamics, by the way. There are many universities and institutions contribute to this effort. And it's been a discussion for a while.
So over the past 10 years, we've gone from from barely any research to a lot of research now.
A lot of research on that one. But in the US, one of the key is the focus is healthcare related problems.
Healthcare.
Solving on that. There's a lot of investment on that.
Uh-huh.
Robots are used on that. For surgical robots, for example, Da Vinci is $1 million and stuff. There has been significant work on
When
that.
you say Asimov, are you talking about Isaac Asimov?
Asimov, the robots, the Japan.
The actual robot. Okay,
actual
not
robot.
not the author, not the guy who wrote the book. Okay, that's very interesting. So, just a few minutes ago, we were talking about these humanoid robots being very expensive and most people not being able to afford it. And I was making a joke about people taking loans, but why? What's the reason for them not being affordable? Is it a material issue or what? Materials issue?
I think for the humanoid robots, because it has a lot of complexity, right, to develop. There is a hardware aspect of it, there is a software, and there is also control part of it. So it's a biped. We were talking about the biped. It's just also being able to balance and stand with two legs and be able to walk and perform things is difficult. So because of these things, these robots are expensive. How expensive are they? They are $1 million. For example, Asimov is $1 million in the research paper I read. Even for rent, is $100,000 for rent from the paper.
To rent it?
To rent it.
Wow.
Yeah. So in the past, I think after that, this is from the Honda's, the Asimov robot.
Yeah.
Even the existing one I checked recently, the Boston Dynamics are expensive too, right? 74,000, things like that. The Spot Mini,
so the mini robot,
the mini robot,
the mini robots are almost $100,000.
That was almost that's expensive, right?
Yeah.
It's not affordable.
Yeah.
So there should be effort required to make affordable, and it's the hands of so many people. It has to go down.
Yeah.
Yeah. It's a very expensive business. Why it's expensive? I think it's not, we calculate how much, for example, in one of the paper we published in Humanoid Robots is a child size, it's a 7-year-old kid size robot. The height is about this in my lab. We calculate our approach was to 3D print instead of other. The printing hour took 300 hours to print the entire robot. Then put together, assemble with the actuators. The actuators are very expensive. Each actuators cost about $500, $600. It's joint. So we have so many articulated joint. Hardware is one of them. And there are, sensors, actuators, controller. Then when you think about the effort required to make this with a skilled worker, skilled person to make this device, I mean, if we look at the infrastructure, overhead cost will be very expensive. So I think that's why, at least at the prototype level, these things are very expensive. If you look at those. Material, maybe less.
Do you think if it gets to mass production, the price will go down?
Yeah, absolutely.
So robots making robots. It sounds like the same movie 20 years ago. Yeah, okay. It's very interesting. But I'm just looking at it from the standpoint of maybe one of your students, currently a professor, maybe currently a student who decides, okay, I'm going to go out and make my own thing. What would they attack as a first, in terms of trying to reduce the cost of making a humanoid robot either at scale or just individually prototyping, for example? What would be the first angle of attack to make it cheaper? I know, first of all, you have to be the skilled maker who is basically not getting paid. So that's out of the question, right? Especially if you're starting a company from scratch, you're not getting paid. Yeah, and it's just you. That's fine. You've taken that out. Now you're not paying $100,000 or more to an employee. But what else can you attack? Can you find, I don't know, you said the actuators where you need a lot of actuators and they're expensive. You said the 3D printing hours, the hours it takes is long, but where would you attack first to make it cheaper?
I think from all these different angles,
All
from
the
different
angles.
aspects. Material is one of them. Manufacturing is another one. Control, you know, but there are different algorithms that should be tested and performed. Sensing the current position of the robot and act immediately, quickly, and perform movement. Identifying the surrounding using vision system, even the existing vision system apply to the robots, not only just vision, but other tactile sensing, distance sensing, and sensing the environment, act accordingly. Those are all complicated problems. So we have to look at from all of them. This should be done in a group.
Yes.
So to solve the challenge from people with a background of materials, people with a background of design, also overall architecture, electrical system. Even look, connection. We ignore connection, right? Just one connection problem for a robot. Figuring out that connection takes you, for a while. So it's a really challenging, but it's rewarding too. Once you figure out and find a sweet spot to find a solution for. But we have to be multitasking.
I see. So is it better to just find state-of-the-art existing parts, components, materials, and maybe that will help instead of trying to make your own? Okay.
Helps,
I see.
Yep.
I see. All right. Let's talk about someone who wants to be an engineer or someone who wants to basically build something in the real world as an engineering focused work in the real world. What kind of projects and hands-on experiences can new engineering majors expect in school nowadays? Like if you're coming from high school into a physical engineering program, like mechanical, electrical, what are people working on nowadays, and what are people excited to work on? I know you probably say robotics, but what else?
I mean, there can be energy. Energy is another aspect. Only energy. How to get energy from wind, for example. UTD is well known for wind energy.
Wind energy, okay.
Just basically, Texas, the focus has been also on how to generate from wind and to connect to the grid to produce power and electricity. Electricity cost is expensive. How to use solar power to power also this heat. How can one convert this heat in summer and then convert it into useful electricity? So these are some of the research directions that are important too.
Okay.
So students who are people who are in a high school plan to join or be a mechanical engineer or an engineer in general should be able. The key is solving problems. Engineers should be able to conceptualize, iterate different ideas, come up with multiple solutions, pros and cons, and then it's not like science. You are an engineer. You conceptualize, you connect the basic physics with the idea that you have, and then you have to make it too. That's the final one. Make it and show and solve that problem. That makes you an engineer. So they should think about how to nurture or make themselves strong, building up their background, and then develop these skills to solve problems.
I see. Fantastic. That's good insight right there for someone trying to get in, regardless of what field what type of research you're trying to do, right? You need to be able to solve a problem and actually build a product and show that it works.
Yep.
Right? Or build a prototype and show that it works. I have a question about in some fields like law or finance, the school you go to actually matters. Like where you do your undergrad or even grad school sometimes matters. Does it matter for an engineer? Does it matter if you go to an Ivy League school versus if you go to some other school that just does okay in terms of your future prospects? I'm looking at it from the standpoint of someone who wants to study engineering and you're thinking about what to do.
Yeah, I see that trend actually, right, from many students and also parents also, and everyone is biased to Ivy school, top 10, top. Yeah. So it's not in general, it's I know the admission from these schools are tough, and the process they make it.
Yeah.
And because they have been there for many years, they have their reputation already, but not necessarily that. Like I said earlier, someone has to, at the end of the day, that person should solve problem and show. It doesn't necessarily graduating from X school and Y school. Then what can you do after that? After you graduate, what have you done? You will be evaluated based on what you can accomplish, whether you are industry or in academia. What have you contributed and what did you show?
Yeah.
And people we can judge it. So people are biased. Yes, it affects when you apply for job placement and application. But the key is that what you can do.
What can you do? So to that point, is it actually more impactful to focus on being self-taught?
Absolutely.
Maybe learning from online sources and some of that non-traditional sources.
Yeah, I encourage self-learning, self-taught as a key because you can go in your own pace, teach yourself, and fill in what you need. But this doesn't replace the regular teaching, because the regular teaching, there are some component of enforcing you. That kind of enforcement is also good, because otherwise, the way you test, you have to do assignments and projects and things like that, and you should be graded. That way, you are qualified and certified. So, self-learning plus some kind of certification or exam is a good way, I guess.
I see. That's good. So, it's good to still have the regular learning. Is it important to have the regular learning to an advanced level? Like, do you need a master's degree or a PhD to basically get very good placement in the job market as a mechanical engineer, electrical engineer, chemical engineer, and all that?
Not necessarily. Actually, some jobs, they may not need PhD.
Okay.
You may be called overqualified.
Yeah. Tell me about that.
Yeah, I've seen some.
Yeah.
They say they don't like to have at that level. So if that's something that can be done by master's level or undergraduate, then there's no need to do that. Yeah. So the level, why someone or some industry or agencies require a PhD hire? So the key is that at the PhD level is the depth and the breadth of the knowledge that makes a difference between masters and PhD. Other than that, there is. So a PhD critically thinking about in deep and wider also. They can have insight more. I'm just talking about the general, as someone who obtained Doctor of Philosophy should have that kind of mentality, and then providing insight to the problem at hand. So for those kind of areas, yes, they require PhD, required to deepen that knowledge.
Yeah.
But in some areas, you may not need.
Right? I see. What about someone who wants to go out and build advanced technologies and commercialize it, basically build a company around some form of advanced physical technology? Would you encourage them to have a PhD first?
Not necessarily, right? So as we have noticed, right, most of these popular companies, it's not necessarily they have a PhD. In fact, they hire PhDs.
They had PhDs. I see.
Yeah. It's all about personal career aspirations and, plan.
Yeah. Fantastic. So then what would be the point of having a PhD? As two of us sitting here having PhDs, what was the point? You're a professor. I'm an entrepreneur.
Yep.
How useful is it outside of the school environment, do you think?
To have a PhD.
Any hard engineering degrees, any physical engineering degrees?
I think it's more having the curiosity to learn something is mainly when you have a PhD. Always you ask questions. In fact, if you have others also you do, but in more deeper, wider kind of perspective, you look at having a PhD makes you to think in that way.
Yeah.
If I put it.
Yeah, it makes you more curious. It makes you ask questions a lot.
Yeah.
About everything. So to that point, if you're going to do it, you probably need to be very passionate about it. You probably need to know what you're doing. It has to be really what you want to do. And one of the biggest problems is getting funded for your research. What's the landscape nowadays for getting funded for research, for projects in the educational environment? What's it like? Is it easier, harder?
Not at all easier. It's highly competitive.
It's highly competitive.
In the US, the research funding is highly competitive, but there are avenues always. If you come up with a great ideas and write it in a clear and well with illustrations, and there's someone who will buy that technology.
Mm-hmm.
So I would say that sometimes it decline in one area, another area will increase. For example, there are many funding opportunities for AI related these days because there are many things that's not understood.
Yeah.
But other fields, so it doesn't mean that other fields are dying, but still the other fields are also requiring someone to explore in different direction. Mm-hmm. Healthcare, energy, education part, these are all different. They have all different aspects.
Yeah, I see. So you can get funded. It's just very competitive. What would you say the environment is like for current students doing research? What's the sentiment like? Because I know it's, as someone who has been through grad school and everything, it's like night and day between the real world and research world. But nowadays the real world is encroaching really hard on everyone. Like we all see what's happening. Is there a difference between the way you perceived things outside of the school environment versus the way your students see it now, your grad students?
I think I don't have much experience on outside. I mean, I work with industry a lot, right? But but after in industry, most of them, they don't spend like in a grad school. The grad school is hard. You have to do your literature, your experiment, and everything. It's a lot of work.
Yeah.
Day and night.
You don't have time to you don't have time to read the news or pay attention to anything.
Many things to do, but I think at least I will say the industry after graduation is less intensive than that.
Oh, it is. It is less intensive. Yeah. So you're saying that graduate students are still very much insulated from the outside world, apart from the work they do with.
It depends if they are exposed to some projects. Some projects are highly demanding. Like weekly report, monthly, or any of some aspect that they have, and other projects may require another. So it depends.
Yeah, I see. So if you had to speak to one of your students who is very entrepreneurial minded, and the person is an undergrad or they're in graduate school doing a master's or PhD, and they tell you, I think I have an idea of what I want to pursue right now, and I want to drop out to pursue it. What do you think? What would you tell them?
I think I will say I will just first have a conversation, because, dropping out, I don't think I will say, okay, at the first time, because, I will say, okay, you are in the middle. All right. So I will have a discussion. For example, every university, there are some kind of research incubators, and then they encourage, our university, for example, encourage graduate students to have their own contribution and have their own business or startups also. The university encourage, and every university is doing that, right? Yeah. So there are avenues that way. I will give those kind of devices, something that I know. But if you are in the middle, I think before you drop out, I'll encourage at least finishing. I mean, this naturally I will give that. But if that person insists, and then if bright, something that's really well thought idea, I mean, I would say, I will leave the decision for that person.
So it's a case by case thing.
Yeah, I will leave the decision, but just give information, whatever I can.
Okay.
Yep.
There are two ways to look at it, right? It's basically how far have you gone, and also what's the competition like? Because if for example you can make headway and your competition is not going to wait for you for 2 years, there might be a good idea to just leave, no?
Yeah, so it
Case
depends
by
on
case.
the business case.
Yeah.
But I mean, we know that making your own business, the market, you study the and other things, it may not go as expected.
Most times it does not.
And most of the time, it's struggle for
most
a few
times
years.
it fails. Yeah.
Yeah.
No, it not just struggle. Most times it will fail. So, all right.
You know much better than me.
Yeah. I've been in these entrepreneurial streets for a while. Okay. What's one piece of advice you would give to someone who wants to be an engineer? I know you've already talked about it. You need to know how to build something and all that, but just re-summarize. Someone comes up to you, you get emails, you get messages from high school students, right? What's the one piece of advice you typically give to them if they tell you they want to be an engineer?
Yeah, for people who would like to be an engineer, my first advice is that's problem solver, right? So identifying problem solver, read materials, understand basics. That this is one of the connection they lose. Without understanding basics and try to be an engineer, it doesn't work. Basic physics, basic kind of forces, mass times acceleration. Connect, because the physics is the one that works for the engineering to happen, right? So I will encourage to have their foundation build, revise if they want to be an engineer. Have a good foundation. If not, compensate that. Study self-learning. Then try to have the necessary skills at that level. And for example, if they are at the high school level, they should have everything completed in the high school level, because they will not get that part in the university. We think that they have done this at the high school already. Basic math, basic physics and things like that. Then when they come to the university, we're talking about something slightly higher than the high school that they have. We'll show new theories, something built on the top of that. And if that one part is missing, it's challenging to come up solutions. So that's the advice I will give. Problem solving, building background, self-learning.
Fundamentals.
Yep, fundamentals.
Fundamentals. All right. How about this one? You have a PhD student or a student in grad school. Based on your experience, you going to grad school, being a postdoc, and also what you know about the stages of going through being an assistant professor, an associate professor, and then what it's like to be a professor. If someone comes up to you in grad school and says, I want to be a professor, what's the first thing you would tell them in this landscape that we're in right now?
Yeah, the first thing, this is what advice I give for all my PhD students as well. In the US, you have to be a professor, you need to publish a lot of papers. Not one, just two or something. No one will accept that. Should have very...
So don't make jellyfish robots, huh?
Published a lot of papers. And then not only just publish in a best journal also that people can call it.
Yeah. And
no one will call you otherwise even for interview. So that's the first thing I will say. And then this is not... I advise when someone joins my PhD program, I advise this the very first day, because it's not happening at the end of the PhD, but it's just started from the day they start PhD. The 4 year, they should accumulate enough journal publication and also thinking about novel ideas. Otherwise, that you can't bring funding, external funding, if you don't have new ideas. And you should have also a good understanding of what exists. So tons of reading is needed. I advise this, and of course you have to teach, and you should have a strong interest in teaching. So this is a couple of advice I'll give.
If you enjoyed this episode, please consider supporting our mission of providing good quality content and conversations from within the hardware tech space. And all you have to do is like the video, share it with your friends, and subscribe to the channel. Thank you for watching.